You can also think about ways how you can possibly scale Ethereum. So the root problem is now Ethereum blocks have no size limit, by the way. So the blocks in Bitcoin have a limit in terms of the amount of text that it contains. I think it's 1 MB at the moment. Ethereum does not have any such limits, but they have a limit for how much computations can be done in one of these blocks. That's referred to as the gas limit, right? Because gas is essentially a measure of the computational cycles that you use. So there's a limit for that, and that effectively limits the amount of processing that can be done. Now, Ethereum, from its very get-go, even in the original paper that describes what it would be doing, has said very early on that they wanted to transition from the proof of work protocol, which they knew worked and which would work and which is therefore operational, to a proof of stake system. And I'll explain in a second what a proof of stake system is. But the important part is that A, that hasn't happened, and B, is a hard problem to solve, right? So conceptually, getting a proof of stake model to work is not trivial. In particular, it's not trivial under the current circumstances where people have locked up enormous amount of value in the Ethereum blockchain, and the transition would require that none of this value can be stolen in any form of attack in some form. Now, there are some blockchains which are proof of stake blockchains that are operational, but they are usually much smaller and they are not as heavily used as the Ethereum blockchain is today. The Ethereum blockchain, by all practical standards, is the biggest and most important blockchain for applications. Now, one solution that would allow scaling are so-called side channels. And there are some really cool solutions that exist, for instance, for payments processing, that could be fully anonymous and that work on the side chain. There's one is called ZK Sync. So it comes from zero knowledge sync, which means basically that there are zero knowledge transfers, meaning nobody knows. So the party that administers these transfers can't see who the other side is. All that they do is they process something. Another part, so now what that involves is what's referred to as a side channel. So think about it as you put money in an escrow, then you have a lot of interactions outside of the main chain, and once you're done with those interactions, you settle back to the main chain as a system which records then just the terminal transactions of any kind. So I have a slide here which shows an example for an electric car, right, where the electric car uses electricity, has transfers from the vehicle, maybe also into the electricity provider, the excess capacity of some form. And at the end of the day, there's a bill being made and that will be settled on the blockchain periodically. And another solution that the Ethereum network has in order to scale better is also the space constraint. And they want to do some form of what's referred to as sharding, where only parts of the blockchain are processed at any given point in time, so everything is split up in shards. Now that's a mathematical and computer science, technologically very advanced problem that has also not been solved, just like some of the proof of stake problems have not been solved. All right. Now let me explain briefly what proof of stake is. Ultimately, what it works, or what it boils down to, is that a group of entities are becoming so-called stakers. So they take money and they lock it up, and that money allows them to become proposers for new blocks. So essentially, that then refers to a different type of consensus algorithm that you use. It uses a staking-based algorithm. So the entities that are there in some form are known to the network, right, because of their stake. And what the system would do is it would select people based on the amount of stake that they have, and then they can propose new blocks. Now, one of the problems that you can see there is, is the problem of shirking that could exist. So one of the problems that we have in proof of work, for instance, there is an incentive that people have to attach only at the longest chain, because they have something to lose when they attach to a different part of the chain. But with proof of stake, you could essentially try to take your new block and attach it to any of the previous parts of the chain, right? So, if there's, in fact, actually you can attach it to any existing block. So what that means is that, you have a proof of stake problem where you have nothing at stake by confusing the network. Now, there are, mechanisms that could be in place to prevent this. The problem is, first of all, I've not seen a fully convincing solution here. Now, there is a paper by Farhad Saleh, and I recommend that you have a look at it if you're really keen. and where he shows basically how you can have how the proof of stake blockchain can work and how it is how it can be in equilibrium. I haven't quite understood how he solved that problem with the nothing at stake issue. So one of the ways how you can think about how you can prevent this, of course, is you have a punishment, which is referred to as a slashing condition. But that is something which is highly controversial because it's not really clear how it works. Anyway, so this is what I'm trying to say is the proof of stake problem is a major problem, and it has not yet been satisfactorily resolved, at least not as far as Ethereum is concerned. It's been promised though since 2014, so we're waiting for it. All right, so here's the one that I wanted to mention earlier. This is the reality check of the current capacity of the blockchain networks. You know, Bitcoin has 7, Ethereum has 30. If you want to be generous, could be 40. There's a system which is called Algorand, where there's a random selection, of people who can select and propose new blocks. It's been developed by an MIT professor, who's also a Turing Award winner. So they can process about 2,000 transactions a second. The Conflux network can do 4,000. There is another algorithm for consensus, which is called Avalanche, developed by Cornell researchers. They can do, they say, up to 10,000, so on average about 5,000 a second. And let's look at the real world. So Payments Canada process around 650 transactions per second. UTL retail sales US retail sales would be roughly 7.7 thousand transactions a second. You can say that as a full payments network for the US, for instance, none of these networks is sufficiently capable at this point to replace it, at least in full. Now Canada, if you look at trading, right, trading of assets, Canada only has about 46 transactions a second, so that's something which is possible to do, although not in a condensed period of time where there's sometimes a lot more. In terms of orders of Canadian equity markets, though, right? So because you can have, when you have fully decentralized trades, you need to register the orders on the blockchain. That's about 3,600 transactions transactions per second that you would need for that. And again, none of the blockchains can even handle the 7th largest market in the world for that. So there's ways to go. Now, okay.